Good afternoon, good evening, ladies and gentlemen. Welcome to another series of tutorials with me, Aubrey. We continue with our lesson on limits and differentiation. This is part 3. If you haven't already, please subscribe to the channel, leave a like, and comment what you would like to see in the next video. All right, so we continue from where we ended. Now, before we go any further, I'd like to address question number 8 because it's a bit different. Though we have a 0 over 0 case, as we learned previously, we have a 0 over 0 case, but since we have this power here, it would be better to take another approach. Same applies to where you have maybe quite all right. L'Hopital's rule can work where you need to differentiate 2 times. For this one, you differentiate. Again, if you're getting 0 over 0, again, you differentiate. If you get 0 over 0, you differentiate. But in a case where it is just like that, there is no problem. But specifically for this one, since we have a power 3, it is best to take another approach. So let me start with that one. So let me switch over to my whiteboard. All right, this method also works, but more specifically, if you see that the numerator and the denominator have a common factor. So basically, if you try to factorize the numerator here, using the product, you get the product by multiplying -6 times the coefficient of x squared. So the product is simply -6. The sum is the coefficient of x, which is just +1. Now you're looking for the factors. We're trying to factorize what is on top there. So we're looking for the factors that can go into the product, or numbers that can go into the product. So we see we have plus or minus 1 can go in there. We have plus or minus 2 can go in there without leaving a remainder. We also have plus or minus 3 can go in there without leaving a remainder. Now we're looking for 2 variables, a and b, such that when you multiply a and b, you get the product, and when you add a and b, you get the sum. As you can see, you have 2 times 3 will give you 6. Now what will give you +1 when added? So it just be 3 and -2. So from the factors, we see that 3 times -2, we are going to get -6. Add them, you're going to get 1. So basically, let me just drag these here. So basically, this can be written as the limit as x approaches 2 over, we just say x plus 3. So that's the shortcut, times x minus 2. That is how you factorize like that. Then you have everything over x minus 2 to the power 3. And the idea here is that when you expand this, you should be able to get back to that. So you just get the factors. X, the factor is +3, so you say +3 times x, the factor is -2, then you're done. Then you see that inside here, x minus 2 and the x minus 2 cancels out, and what we are left with is the limit as x approaches 2 of x plus 3 to the power 3, which will just be simply, we plug in 2 now, we have 2 plus 3 to the power 3, which is just 5 to the power 3, which can be simplified as 125. Which can be simplified as 125. So that is what you do here. So there are times this method works more especially in cases where you see that the numerator and the denominator have a common factor. you can use this method, because L'Hopital's rule, it will be difficult for you to differentiate here, or maybe it is possible, but it will take you a lot of time to differentiate. So you can simply simplify like that. Now we go on to what we promised yesterday. All right, so we are looking at how to go about these three problems. So this is the same approach that we use for this, and that. All right, so this is very simple. So as you can see, we have a radical plus a number. Here we have a radical plus a number. We have a radical plus or minus a number there. So minus a number there. So these are other examples. This, once you know how to do any of these, you'll be able to do. So again, when you plug in your values directly, you get a 0 over here. You get a number over 0. This will be 7. That will be 6 over 0. Here you get that is 0 over 0 as well. So this is undefined. Actually, for this one, yeah, you could go with L'Hopital's rule, but I'll show you the method that you could take for this one. We could take for this one, right? We could take for this one. So whenever we have radicals separated by a plus with anything here, we can take this approach anytime. All right, so let me switch on to my whiteboard. I'll do number 13, and you should be able to do number 6 and number 9 there. All right, so let's switch on to our whiteboard. All right, so this is our question. Now for this one, this is very simple as well. So as you can see, I have color coded the radical. So now I'm going to introduce you to what we call conjugating the function. All right, so basically what we do is we look at the radical part. Okay, so whatever part has a radical, so for instance here the radical part is on the denominator. All right, so what we'll do is we'll write the part that has the radical, which is this. So we say root of 1 plus 3x, and there is 1 here. All right, so now how you conjugate, you introduce the inverse or the polar opposite of the radical. So here we have a positive. As you can see, we have a positive, meaning that here we're going to have a minus. The sign that changes is just the sign of the radical. Then this maintains its sign, which is -1. Then since we don't want to change the meaning of the question, we also multiply the numerator by the same thing, which is negative root of 1 plus 3x, then -1, like that. All right, so this is what we do. If the radical is on the numerator, we get the whole thing. Then what we change is the sign of the radical. If it is plus here, it will be minus. If it is minus, it will be plus. So that is how you conjugate. Again, you're not changing the meaning of the question because this and that would divide. It is just simple. So here now we can multiply the numerator and the denominator. So we multiply the numerator, so we have limit as x approaches 0, we say this times that will be -x root of 1 plus 3x. Then we say minus x. Then we do the same thing for the denominator. So it will be this. As you can see, this is all right. So we say this times that. Okay, so this times that, so there will be a negative. Since they have same bases and their power is half, so what will just remain is 1 plus 3x. Okay, this is indices, same bases. This is x, 1 plus 3x, 1 plus 3x, and the root is just to the power half. So this is something as 1 plus 3x to the power half times the negative of 1 plus 3x to the power half. And when you have similar bases, the powers add, so you just remain with +1 there. All right, so That is that. So this times that, then this times that, that will be negative root of x, sorry, 1 plus 3x, 1 plus 3x, 1 plus 3x. Then we say negative 1 times that, that will be plus root of 1 plus 3x. Okay, then we say negative 1 times negative 1, that will be plus 1. Okay, so here what we do is we simplify further. So we say this will be limit as x approaches 0. On top, we can factor out the negative x. So we factor out negative x. What we remain with is the root of 1 plus 3x plus 1. Okay, and at the bottom, we see that this and that will cancel out. They are polar opposites of each other. So what will remain with, we can distribute the negative here. So we have negative 1, negative 3x plus 1. Okay, then all right, then now we have limit as x approaches 0 of negative x on top. Then we have root of 1 plus 3x plus 1 divide by, we see that this and that will simplify, so we'll just remain with negative 3x, negative 3x. And as you can see, since the x is factored out completely, we can cancel out the x here and here, in fact even the negative and the negative. Then what we remain with is the limit as x approaches 0 of the root of 1 plus 3x plus 1 divided by 3. Then now we can apply, or we can plug in our limit. So we plug in 0 there. What will remain with is just root of, this will be 1 plus 3 times 0. That will be just 1 plus 1 all over 3, which is just equal to the root of 1 is just 1 plus 1 over 3, which is just 2 over 3 as your final answer. So that is the approach that you're going to take for all those that have radicals separated by a number like that. So you conjugate like that. All right, so see you in the next lesson. So in the next lesson, we will be looking at these that have infinity in them. So for these that have infinity in them, we take a very, these are simplest to work out. These are the simplest to work out. So we take these that have infinity in them, and we see how we can go from there. All right, so have a good evening.